Hello students. In this session let us discuss type 4 problems, and in the previous sessions we have seen type 1, type 2, type 3. So type 1 was verify the function as analytic and find the derivative problems, and type 2 was construction of analytic functions, and type 3 was finding the harmonic conjugate type of problems. So what does type of problems are? This type 4 problems are all the combination of type 1, type 2, type 3. So equation can be, some hint will be given and it will be asked you to find something. So whatever has been asked you to find, accordingly you have to use the suitable method and find the required answer. So let us take the problem straight away and work out. Here there is no suitable particular working rule can be rolled out, as it is a combination of a combination of these three problems, a combination of type 3 problems. So take a first example. Find the analytic function f of z is equal to u plus iv, and given u minus v is equal to e to the power of x cos y minus sin y. So this is a given problem, and it is what is asked you to find. It has asked you to find function as analytic. You have to find the analytic function using the given equation. So what is given equation is? Given equation is u minus v is equal to e to the power of x into cos y minus sin y. So differentiate this equation with respect to x and y. So when we differentiate with respect to x, we get ux minus vx is equal to cos y minus sin y is a constant, keep it as it is, and differentiation of e power x is e power x itself. Call the equation as 1. Similarly, the given equation u minus v, this one, u minus v is equal to e to the power of x cos y minus sin y, differentiate that partially with respect to y, you get uy minus vy is equal to e power x into minus sin y minus cos y, and call this equation as 2. And now you can observe ux, vx, and here uy and vy is there. So there are four unknowns actually. Ux is one unknown, ux is one unknown, and vx is another unknown, uy is one unknown, uy is another unknown, when vy is another unknown. So there are four unknowns together here. So it is difficult to solve with two equations with four unknowns. So keeping it in the mind that if two equations with two unknowns, it is easy for us to solve. So we are going to convert equation 1 and equation 2 as it has only two unknowns. So how do we do that? So let us use the CR equations. So CR equations in Cartesian form. Why we are using CR equations in Cartesian form here? Because the given problem is in the Cartesian coordinates, so you have to use CR equations in Cartesian form. So ux is equal to vy and vx is equal to minus uy is the Cartesian equation, CR equations in Cartesian form. So consider your equation 2. There you are going to substitute these CR equations. So we get minus vx minus ux is equal to minus e to the power of x into sin y plus cos y. So this you can take out minus sign outside and cancel with this minus. This minus gets cancelled. So you get ux plus vx is equal to e to the power of x into sin y plus cos y, and call this resulting equation as equation 3. So now equation 1 and equation 3. When you observe, you have equation 1 which has ux and vx, and even your equation 3 is having ux and vx. So we have two equations with two unknowns. So it is easy to solve by using the simultaneous equations concepts. So let us solve equation 1 and 3 simultaneously. So when we do so, you can look at this, write your first equation and write your equation 3. Equation 1 and equation 3. So when we want to subtract, the positive signs become negative sign. Here it was positive became negative. Here also it is negative, negative and negative. So now on adding these equations, ux and minus ux get cancelled. Minus vx and minus vx gives you minus 2x, and e to the power of cos x minus e to the power of sin y. And when we look at this, this 2 gets cancelled because of one positive and one negative, and this both are negative, so you get minus 2 e to the power of x into sin y. So minus on both the sides, here we have minus on both the sides gets cancelled, and 2 also gets cancelled, so we get vx is equal to e to the power of x into sin y. So we have found Vx now. So let us substitute this Vx in any one of the equations. So consider here equation 1 and substitute your equation for Vx. So in equation 1 you have Ux minus Vx. So we are substituting for Vx here, and on the other side it is the same. So on solving this, you can see e to the power of x sin y, this negative, and when it goes to the other side, when it goes here, it becomes positive, and that positive term gets cancelled with this negative term, and u to the power of x is equal to e to the power of x into cos y, and ux is equal to, the remaining is e to the power of x into sin y. So you have found vx, and we have also found ux now. So now consider your equation for f dash of z. So our aim is to find f of z. So there is a standard equation which we are regularly using in the problems, which is f dash of x in Cartesian form, which is given by ux plus I into vx. Substitute for ux and substitute for vx. And now we have to substitute x is equal to z and y is equal to 0. You can try to recall your equation now, problems of type 2, construction of analytic function. This is how we have done. And when we substitute x is equal to z and y is equal to 0 in f dash of z, we get f dash of z is equal to e to the power of z. But we have to get f of z. So in order to get f of z from f dash of z, you need to integrate the equation with respect to z. So integrate f dash of z, we get f of z, which is equal to integration of e to the power of z into dz plus c. So f of z is equal to e to the power of z plus c is our analytic function, which is our f of z. So let us consider another example. So here f of x, if f of z is, consider this as a second problem. So if f of z is a regular function of z, show that dou by dou x of modulus of f of z whole square plus dou by dou y of mod of f of z the whole square is equal to mod of f dash of z whole square. So when we look at this, there is nothing more so it is a different kind of problem. It is not it is not of type 1, it is not of type 2, it is not of type 3, and it is something different, and it is like take LHS and prove that is equal to RHS kind of problem, or take RHS and prove that is equal to LHS. So whichever the way is convenient for us and which gives the solution in a faster way, that method can be applied in order to get the required result, which is this. So now what we know, so given is f of z is a regular function. So what is f of z? F of z is always u plus iv, and it has been given as it is a regular one. So now what is mod of f of z? So by the definition of modulus of function, modulus of f of z is square root of real part whole square plus imaginary part the whole square. So mod f of z is equal to u square root of u square plus v square, and let us say this is equal to a function phi. Call it as equation 5. So now let us consider dou square phi by dou x square and dou phi by dou y the whole square. Why we have considered this? Now observe your given equation. This is what you have to prove, and mod of f of z we have taken it as phi. So dou phi by dou x the whole square and dou phi by dou y the whole square. So instead of modulus of f of z, we have just replaced it by phi. So now this is what we are going to consider, and you have to prove the answer is mod of f dash of z whole square. So now dou phi by dou x can be written as phi x, and the square on it remains as it is. Dou phi by dou y is phi y whole square, and again mod of f dash of z whole square is as it is. So now consider here phi. What is our phi? We have just in the previous, before 2 steps, we have seen phi is equal to square root of u square plus v square. So take square on both the sides. So phi square is equal to u square plus v square. Call it as equation 1. And now differentiate equation 1 with respect to x. Why we want to do that? So this is what we want, so we are doing it. So differentiate equation 1 with respect to x. So differentiation of phi square is 2 phi, and differentiation of phi is phi x. Similarly, on the other side, 2u into ux plus 2v into vx. This is when we differentiate the equation 1 with respect to x. Similarly, differentiate 1 with respect to y, we get 2 phi into phi y is equal to 2u into uy plus 2v into vy. Call the result as equation 3. So now square and add equation 2 and equation 3. So when we square equation 2, we get 4 phi square phi x square plus 4 phi square phi y square. And on the other side also we have to square. So when we square equation 2, you get 2u into ux plus 2v into vx the whole square, plus equation 3 gives you 2u uy plus 2v into vy the whole square. We have squared equation 2 and we have squared equation 2 and 3, and we have added equation 2 and 3 after squaring. So now take out the common term, take out the common 4 5 square here and 4 5 square here, take it outside, and remaining is 5x whole square plus 5y whole square. And here when you expand this by using a plus b whole square and this also by using a plus b whole square, we get you can expand it by using the formula, and you can also take out 2 here, 2 here and 2 here, 2 here and 2 here can be taken out as a common term, and because of the square it becomes 4. So when we expand it by using a plus b whole square formula and simplify, we get this result. And now also from CR equations we have ux is equal to vy and vx is equal to minus uy. So let us substitute these CR equations in the above steps wherever it is applicable. So 4 5 square into 5x square plus 5y square is equal to 4 times of u square plus ux square. The first term, this term is there as it is, and you can observe the second term v square vx square is also there as it is, 2uv ux vx which is also there as it is. Coming to the next expression, this one you have u square where uy is been replaced by minus vx by using CR equation, and v square is there as it is, and this vy has been replaced by ux, and 2uv uy vy can be replaced up to the suitable term, so you get negative 2uy vx and ux. Why? Okay, now on simplifying, whatever the terms gets cancelled, like positive terms and negative terms you can cancel, and the resulting expression will be 4 times of u square into ux square plus vx square plus v square into ux square plus vx square. So on the other side we have 4 times of 5 square into 5x square plus 5y square, and here take out the common term 4 into u square plus v square, and resulting is that so 4 5 square into 5x square plus 5y square is equal to 4 u square plus v square is nothing but 5 square. So that is ux square plus vx square, and 5x square you can cancel 4 5 square on both the sides, this term and this term gets cancelled, so remaining is 5x square plus 5y square is equal to ux square plus vx square. Call the result as equation 4. And now consider your f dash of z. So what is our f dash of z from the standard result? Choose ux plus I vx. So take the modulus for it. So modulus is square root of ux square plus vx square. And mod of square, taking the square on both the sides, you get a square root gets cancelled and remaining is u square plus va square vx square. And call the result as equation 5. Now equation 5 and equation 4, observe your equation 4 RHS is ux square plus vx square, and equation 5 RHS is also ux square plus vx square. So since RHS of both the equations are same, we can equate the LHS of both same equations. So we get 5x whole square plus 5y whole square which is equal to modulus of f dash of z whole square. What is our 5x and 5y is? Dou 5 by dou x mod of f dash of z, and dou by dou y of mod f dash of z, and on the other side we have modulus of f dash of z whole square. So this is how you need to prove the result. So look at another problem. If phi of x comma y is differentiable function and f of z is equal to u of x comma y plus I into v of x comma y is regular function, then show that dou phi by dou x whole square plus dou phi by dou y whole square is equal to dou phi by dou u whole square plus dou phi by dou v whole square into modulus of f dash of z whole square. So this is our problem. So let us look at the solution here. So what is our solution? Let us treat phi as a composite function, treating phi to be a function of u and v, and where u and v are functions of x and y. So these are the imaginations or assumptions that you have to do in prior so that you can do the problem in a better way. So by chain rule, dou phi by dou x is dou phi by dou u into dou u by dou x, dou phi by dou v into dou v by dou x. So because u phi is a function of u and v, and u and v are a function of x and y. So phi to be differentiated with respect to x means that you have to use u and v and then only you can go with x. So phi to be differentiated with respect to x, phi to be differentiated with respect to x, and 5 with respect to u, and 5 with respect to u and u with respect to x. Again 5 with respect to v and v with respect to x. So dou phi by dou x is nothing but phi x, and dou phi by dou u is phi u. Dou phi by dou x is ux. Dou u by dou x is ux. Plus the next term. This term is dou phi by dou v. It can be written as 5v, and dou v by dou x is nothing but vx. So now similarly differentiate the equation with respect to y. So dou phi by dou y can be written as phi with respect to u and u with respect to y, plus phi with respect to v and v with respect to y. So hope you remember the chain rule concept. So we have used that. And dou phi by dou v, this dou phi by dou v is nothing but 5y, and this dou phi by dou x u is nothing but 5u. Dou u by dou x is uy. Dou phi by dou v is 5v. Dou v by dou y is vy. So now consider, therefore 5x square plus 5y square, square and add equation, this and this you can add. So we get 5x square and 5y square. So square, on the other side also you must add. So this side also must be added, squared and add. This also square, it should be squared and added. So that is what we have written here, squared and added. So expand by using a plus b whole square formula. This two terms are there as it is, and this can be this is expanded by using a plus b whole square. This has also been expanded by using a plus b whole square. So a square plus b square plus 2ab plus a square plus b square plus 2ab. So now let us use CR equation so that some of the equations can be cancelled. Some of the terms in the equation can be cancelled. So let us use ux is equal to vy and vx is equal to minus uy. So 5x square, 5y square will be there as it is. So look at this first term. So this is there as it is. This is also there as it is. This is there also as it is. When you come here, uy has been replaced by minus vx. And when you come here, vy has been replaced by ux. And when you come here, you can look at that uy has been replaced by vx, and vy has been replaced by minus ux. So therefore, on simplifying, 5u square is a common term, remaining is ux square plus vx square. 5v square is a common term, remaining is ux square plus vx square. So again ux square plus vx square is a common term, remaining is 5u square plus 5v square. So now consider your f dash of z. So f dash of z is ux plus ivx. So we know that, and we will keep using this in the problems. So a modulus of f dash of z is square root of the real part and the imaginary part. Square root of squares of the real and imaginary part. So now modulus of f dash of z square is ux square plus vx square, and call the equation as 2. And now replacing 2 in 1. Substitute this 2 in your equation 1. So we get 5x square plus 5y square is equal to 5u square plus 5v square into modulus of f dash of z square. So replacing it for 5x, 5y, 5u, 5v, and this we get the required result. So this is how you need to work out the type 4 problems. Each and every problem will be of different kind. What has been asked you to find is important, and what has been given, based on that you have to decide what method is suitable to get the required solution, and then you have to proceed accordingly.